in this question, it says a stone is projected vertically upwards from ground level. The distance above the ground, d meters, at t seconds after launch is given by 12t minus 4.9 t square. How long does the stone remain 2 meters above the ground? So this is the modeling question for inequalities and quadratic equations. And for us to solve this, we need to first figure out what our equation will be. So if you look at the keywords over here, it's 2 meters above the ground. Since it's 2 meters above the ground, so it means that we'll have an inequality where it's going to be 2 is less than 12t minus 4.9 t square. We're trying to prove that this equation, when we solve with the values we get for t, they're going to be for those values of the distance that are greater than 2. Hence, 2 is less than 12t minus 4.9 t square. That is the inequality that we're going to solve. 4.9 t square minus 12t plus 2. Then we're going to use the quadratic formula to solve this. Minus negative 12 plus minus square root of minus 12 whole square minus 4 times 4.9 times 2 divided by 2 times 4.9, which is going to be 12 plus minus square root of 104.8 divided by 9.8. So that's going to equal 12 plus minus 10.24 divided by 9.8, which basically gives us two values, which are 2.269 seconds and 0.179 seconds. Now, this is still not the final answer. What we're going to do now is see how long does the stone remain 2 meters above the ground. So since it's an equality and it's a quadratic inequality, I'm going to make a quick graph and 0.179 over here, 2.269 over here, this is the graph that we have. And since the inequality was less than, that means we look at the values under the y-axis. So over here, t is increasing at 0.179 and it's decreasing at 2.269. So which means the time would be the difference of these two. 2.269 minus 0.179. minus 0.179, which is going to be 2.09 seconds. That is your answer.